So this is a real quick little ditty on protecting your keys or why you need a key store. And he didn't let me bring my own notebook up here, so I'm going to have to figure out how to use this one. See if this works. Oh, yeah, it does. So, since I only got 10 minutes and I'm not familiar with this notebook, I have 15 minutes, okay? And these aren't the slides that I wanted, but that's tough because I only got 15 minutes.
Should go right or left. See that?
Oh, yes, okay, so up, down.
Or right, left, right, left.
Oh, right, what is, oh, same thing?
Yeah.
Okay.
Is there a different presentation on there?
Okay.
You wanted, or?
No, this is fine, this will have to do. Okay, so how come when you enter a password, a lot of these password managers make you put in these, these non-numeric keys like bang or ampersand or $, right? So here's the reason. Well, first I should tell you that when you put in any kind of text at all, the computer translates that to binary, right? Ones and zeros. So if you're inside the computer looking out at Alice, this is what you see. That joke didn't go over very well, so we'll try another one. So here's the binary representation of a bunch of A to Z's in cap and A to Z's in lowercase. Do I sound really loud to you? I sound really loud to me up here. It's okay? It's what? Oh, I'm sorry. I'll step away from the mic and talk a little lower. Yeah, you guys can all go back to sleep, and only people in the front will hear me now, right? So if we take the word secret, okay, that's right there in the bottom of the screen, S-E-C-R-E-T, and we look at the binary representation for those characters, here's what we see. What pattern, if any, do you immediately discern from those characters? Well, let's see if it's on the next slide. The pattern is, if you'll note, that the first number is always a 0. The second number is always a 1. So already, you've given the cryptanalyst a reduced search space when he's looking for your particular passphrase. Yes? That's not good, folks. Because not only have we reduced it, if it's an 8-bit password, each time the cryptanalyst knows a particular number has to be something, you divide by 2. So in this case, we're really restricting the cryptanalysts. We're saying, hey, you don't have to search through all numbers from 0 to blah. I'm telling you that you can skip a whole bunch of numbers if that particular character uses an English letter from A to Z cap or A to Z small. This is a big, big deal. And this is the reason why a lot of password managers say, hey, put something in, that's not A to Z. I'm going backwards. I've got to go forwards. Okay. So here's a good example. Here's secret key in binary. Normally, the cryptanalyst would have to start at 1. Can you still hear me? Normally, he has to start up here and go, okay, I got to search through the entire space of all numbers from all zeros to all ones. That's what he's got to do to find your particular representation of your secret key. By only using letters, A to Z, cap and lowercase, you're saying to him, hey, forget this. Forget going through 300 trillion secret keys. You don't got to. Because here's the pattern. Look at this. Every one of these letters in binary starts with 0, 1. You don't got to search all those cryptanalysts. You don't have to do what we call in cryptography an exhaustive search. We have a question from the peanut gallery.
Are you assuming they're using the ASCII thing as a direct key rather than through PDF?
Am I assuming they're using I'll go back to the mic. So the question is, am I assuming that the system is using the exact phrase as the password? Am I getting that correct? Okay. And it's not doing some sort of translation, with a hash function or something like that to turn that into something more difficult to guess. Okay. Yes, I'm assuming that the attacker knows the translation function that takes this key, that takes this passphrase into a secret key. So he's either using a SHA hash, MD5 hash, whatever you please. Maybe he's got some other stuff in front. But a guy named Kirchhoff, almost 150 years ago, came up with the single most important principle in cryptography. And that is, you always assume that your attacker knows your method, okay, and can reproduce your method at will. So yes, I'm assuming that this is the key, but I'm also assuming that the attacker can put all these possibilities through that particular translation function, which will generate the actual secret key. Was that a sufficient answer? Oh, great. Thanks for the question. So, is this working? By knowing that you're only using lower and uppercase letters, you've reduced the search space for the cryptanalyst. Now, the cryptanalyst doesn't have to search 10 years to find your key. He's only got to search one day, and you're toast. You're sitting there wondering, how did I get hacked? So you input one of these non-alphabetic characters, and you start filling up those bits, which he normally knew what they are. That's what a Keystore-generated key does for you. When you use a Keystore, or when you use a key maker, you're going to get, the Keystore will manufacture that key, and will use all the possible bits in the construction of that key. That just shows you how my program does it. I don't want to do that because it's not fair, it's advertising. Now I'm going to talk about, that's the reason for a Keystore key. Gotta go back to the mic, I keep on forgetting, I like to walk around. The other reason to use a Keystore is that you control who gets copies of your Keystore. You can mail a Keystore out to someone. It's already encrypted, and it has a single passphrase. A single passphrase means that you only have to remember one passphrase and then recover the entire Keystore. So you can have multiple number of keys in the Keystore. Each one has an alias to let you identify it. So you could have one key called business opportunities, one key called love letters, one key called messages to Fred, whatever. Your key will not be business letters. It's whatever the Keystore puts there randomly for you, and it's a much, much better key. So you have two reasons for a Keystore. One is it makes much better keys than a human can ever make. And the second reason is you get to transfer all those keys or some subset of those keys to a particular person that you want to share your keys with. And the third reason is one key does it all for you. That may be as important as having a Keystore generate your keys because it's just way too tough to remember anything more than a couple of keys. You just don't do it. You end up writing them down, and then they're exposed. You end up writing them down more than one place. You put some on your disk, some in your phone book, some on your smartphone. This is not good, right? Because they're coming for you. That's for sure. That's the reason for Keystores. I got 4 minutes for questions. The comment was, another reason for a Keystore is that you get to store really good keys that you can use as a password to different websites you access. And no one's going to try a key that's got a lot of weird letters and numbers in it. You don't have to remember it. You have your Keystore alias, which says something like password to eBay or password to Amazon, and then a really strange looking key pops up, which, not that no one's going to guess, but the idea in cryptography is to make it just tough for your attacker. And you don't want to be one of the low-hanging pieces of fruit that these harvesting programs come along and just grab the easy stuff. So that's the reason. And I'm done with 2 minutes to spare, and that's enough time usually to get away.